so sliding across the page, we're going to talk about rhombuses or rhombi. Now, rhombuses are another form of parallelogram. Rectangles were a specific type. They had some additional properties. Rhombuses are a different type. They are not the same as rectangles, but they are under the bigger category of parallelograms. So they also use all 5 properties of parallelograms. Plus some of their own as well. These have 3, just to give you an idea of how to space out the rest of your column. On a rhombus, remember this is going to be number 6 because 1 through 5 came from the parallelogram properties. Number 6 is that all sides are congruent. You're thinking, well, Ms. Wright, wouldn't that make it a square? Well, possibly. So we're going to draw a parallelogram where all of the sides look to be the same. Just do your best on that. I know that can be kind of weird and hard. So to make sure that we have that noted, we are going to mark all of those sides congruent to each other. I hope that's sharing. So I'm also going to draw this a different way. Another way that you might see a rhombus is kind of tipped up on its side, and it's going to look kind of like a diamond. So both of those are some pretty normal ways to see a rhombus. I just don't want you to think that it has to be tipped up on its side as a diamond in order to be a rhombus, or that it has to be kind of flipped over flat like this to be a rhombus. Both of them are acceptable. Property number 7 of a rhombus is that the diagonals are perpendicular. I'm going to put the symbol, but you can write the word perpendicular. I guess I'll do that too. Perpendicular. It's that upside down T. So I'm going to draw us another rhombus as best I can. And when you draw your diagonals, if you've got your rhombus kind of close, you'll see that those kind of look like they make a right angle, and they do. So just like on the diagonals of a rectangle where we were using Pythagorean theorem to find the length of the diagonal, we can also use the Pythagorean theorem over here. It's just that your right angle is in a different place. On your rectangle, the right angle's on the angle that is from the 2 sides, your length and your width. But you still have a right angle here, even though it's in the center where the diagonals meet. So we're still going to put over here a little star, right triangles, and Pythagorean theorem. A squared plus b squared equals c squared. So we're not necessarily going to do an example of that because we just put a couple of examples over on the rectangles column, but Pythagorean theorem can be used to solve for any of the sides of a right triangle. And you have 4 right triangles when the diagonals of a rhombus intersect. So you could use it to find, for example, this 1/2. And you know that this is half the diagonal because on all parallelograms, the diagonals bisect each other. So then you could double it to find the total. Or vice versa. You could do this one, find this half, and then double it to find the total length of the diagonal. Or maybe you're given the diagonals and you can use it to find the edge, and then all the edges of the rhombus are the same size. Last property for rhombuses, number 8, is that the diagonals bisect opposite angles. Diagonals bisect opposite angles. So on your rhombus, the diagonals bisect each other because it's a parallelogram. And they also bisect the opposite corners because that's what rhombus's diagonals do. So we're going to use some more color coding here. So this top part and this bottom part, those are going to be congruent pieces. Since the opposite angle is congruent as well, this is going to be the same as this, and these are both the same as these up here, right? So you have 4 congruent blue angles if you're using blue like I am. Then go in the other direction. You have a congruent angle here and here because that angle got cut in half. This angle too, which is congruent with the opposite corner, this got cut in half. So you have 2 more smaller congruent angles. So all the greens are congruent, all the blues are congruent. And those are your properties of rhombuses or rhombi. Now down at the bottom of your sheet, you should have a little bit of space, I hope. And down at the bottom, we're going to put squares. Just put this wherever you have room. We're not going to write very much about squares, but we do need to draw arrows from all of these other columns over to squares. Squares have all properties of parallelograms, plus rectangles, plus rhombuses or rhombi. So a square is all of the above. We had 5 properties from parallelograms, and then we had 5 additional properties, 2 from rectangles and 3 for rhombuses. And a square meets all of those criteria. All 10 of those facts are true about squares. Squares are the most regular quadrilaterals because all of the angles are the same. All of the sides are the same. All of the angles get bisected. All of the, both of the diagonals are congruent and they both get bisected. Everything is congruent and parallel and matches up really, really nicely in a square. And your diagonals are also perpendicular. I forgot to say that. So we're going to use this little section over here to kind of draw a slightly neater flow chart. So we're going to put parallelogram. Leave a little space over here and a little space over here. Under parallelogram, you have rectangle and you have rhombus. And then they kind of go back together and we have squares. So that shows you the categories and how they work together. Parallelogram is the bigger category. Rectangle and rhombus are kind of equal categories. They're not overlapping at all necessarily, unless it is a square, and a square is everything that is above it. Now, let's not forget that parallelograms actually are under the category quadrilaterals. So quadrilateral is really the big picture topic that we're talking about. There are 2 more kinds that we're going to talk about that are on the back. First one is a kite. And there are no subgroups of kite. Just a kite is a kite is a kite. And in addition to kite, you have a trapezoid. ran out of room. And a certain kind of trapezoid that we have is an isosceles trapezoid. Okay, so this kind of gives you the breakdown of what goes where. If you want to box them in to make it seem a little neater, you're welcome to do that. And as soon as you've gotten your flow chart done, flip it over on the back. We're going to finish up our notes with kites and trapezoids. Now, the good news is kites and trapezoids are not quite as regular as parallelograms and rectangles and rhombuses and squares. So there's not going to be quite as much to write about them. But they do have some properties that you need to be aware of. So on the back, we're going to put kites, K-I-T-E-S. And then we're going to put trapezoids. And then kind of like we drew that arrow down a little bit from parallelograms to rectangles, we're going to do the same thing, kind of down a little bit, and we're going to call these isosceles trapezoids. And here we go. So I'm going to start with kites. A kite looks just exactly like you think it's going to look. I'm going to draw just a sketch up here of a real basic looking kite. Okay, the kind that you flew when you were 5 years old, right? That's a kite. And the first property is really not a property, but it is a fact, just kind of a reminder. On kites, opposite sides are not parallel or congruent. Opposite sides are not parallel and not congruent. So it's just re-emphasizing that we are no longer talking about parallelograms. This is a totally different category of quadrilateral. Opposite sides are not the ones that have relationships in kites. So for fact number 2, which is really the first positive statement, there are 2 pairs of congruent sides. I would not say that they are, I don't want to say that consecutive sides are congruent because that's not true all the way around the shape. But the sides that are congruent do touch. So this one is congruent with this one, and this one is congruent with this one. And you can see that. Sometimes your kite might look a little more like a rhombus than you visually would be able to, or than you visually would prefer it to. So go with those markings to make sure that you know what you're looking at. Fact number 3 about a kite, or property number 3. On a kite, there is exactly 1 pair of congruent angles. Exactly 1 pair. There's not at least 1 pair, just 1 pair. And I'm going to go ahead and tell you where it's going to be every time. It is where the 2 non-congruent sides meet. So on a kite, you can see that this angle is pretty acute. And even though this other one over here, it might be a right angle, but it might be acute also, they're not anywhere near the same size. The ones that are the same size are the ones on top and bottom. So let's mark this here, mark this here. And that's always where they're going to be. Where the two non-congruent sides meet, you have congruent angles. Okay, property 4. In a kite, the diagonals are perpendicular. And I wrote the signal, or wrote the word on the front page, so I'm just going to use the symbol now. And you know that kites have perpendicular diagonals, because when you were little, like if you ever went outside and tried to actually make a kite out of some sticks and some string, the first thing you did was you picked up some sticks and you put them like that. And then you tried to like connect something or maybe wrap some newspaper around it or something like that. You knew, even before you knew what perpendicular was, how those lines were supposed to go. Don't overcomplicate it now that we have better names for it. Number 5, last one. And you don't need anything across the bottom of this page, so you can use all the way down to the bottom if you want. Last property for kites is that one diagonal will bisect. It will bisect the other diagonal. And it will bisect the non-congruent angles. One diagonal will bisect the other diagonal and the non-congruent angles. So on our kite, let's draw a diagonal and another one. So let's just look at it and use some common sense. Only one of those diagonals looks even remotely close to being cut in half. Is it running up and down, or is it running side to side? The one that gets cut. Yeah, it's up and down. So this part and this part are congruent. So that means that this diagonal is the bisector. It cuts that line, the other diagonal, in half, and it also cuts the non-congruent angles in half. So this and this are congruent. And on the other end, like where you would attach the little string and fly your kite, those are congruent. Notice these two are not congruent sets. All 4 are not the same size, but it cuts each one of those ends in half. And that is kites. Just 5 little properties. Also forgot up here, anywhere that you have a perpendicular, you're going to be able to use Pythagorean theorem. So we're going to put one more time, right triangles and Pythagorean theorem. A squared plus B squared equals C squared. All right, so last category, trapezoids. Trapezoids have 4 properties under the general category of, trapezoid. A trapezoid in general doesn't have to look like we normally think it does. I mean, it could look like that. What we normally think of is an isosceles trapezoid, where you have like 2 parallel lines, and then you have these 2 little lines that go out like this, and this matches this. Now that is a type of trapezoid, but don't think that they all have to look like this. Some of them can look kind of like this little boot right here. Some of them might go in on both sides, but just not in too much. They might even kind of go out. It might almost look like a parallelogram. The only thing that has to happen with trapezoids, for it to be a trapezoid, as far as the lines and how they connect, is that there has to be exactly 1 pair of parallel sides. Exactly 1 pair of parallel sides, and we're going to put the word under there too, called bases. Now, base does not have anything to do with what's on the bottom. It's a little bit weird because normally we would think the base of something needs to be the bottom. But in trapezoids, the bases are just the parallel sides. So I'm going to draw a trapezoid intentionally where the bases are not on the bottom. Okay, so I started kind of like a rectangle with one side up higher than the other, and now I'm drawing down this way. These two sides are going to be parallel, so those are our bases. And then I'm going to put out here, bases do not have to be top and bottom. And you need to know when, or you need to know which sides are the bases and how to identify them. Sometimes your problem is just going to say like the base angles of an isosceles triangle, blah, 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 blah. And if you don't know where the bases are, you're not going to know which angle properties to use. So the bases are these parallel sides. Second thing that you need to know about all trapezoids is that trapezoids have a mid-segment. And that mid-segment is parallel to the bases. And connects the midpoints of each leg or each side. So connects the midpoints we're just going to say of the other sides. So sometimes, actually fairly often, if you see a question about trapezoids, it usually does ask you about the mid-segment because there are several properties that go in with that. So let's draw ourselves a trapezoid. And I drew one that intentionally did not have a little right angle because I gave you an example of that up here, but it's also not isosceles. This line and this line are going to be parallel. And you need to find your midpoint and your other midpoint. And I'm going to draw just like a dashed line. That would be a mid-segment. It might be dashed, it might be dotted, it might be solid, it doesn't matter. What does matter is that it cuts both of these in half. So there's marks for congruent to show that it's cut in half. Let's do that on the other side too. Marks for congruency to show that it's cut in half. And I'm going to put parallel right in there to show that it's parallel with the two bases. The third property has to do with that same mid-segment. Mid-segment is, well, actually, let's put mid-segment's length is the average of the bases. This is another one that gets used a lot because you can do this with numbers or you can make it a little more complicated and they can make you some problems that have like expressions in there. So let's draw two. Draw it like that. Let's put a 10 at the top and a 20 on the bottom. And you can average 10 and 20 in your head. You don't need to write that down. But we're going to go ahead and write it down even on the simpler examples so that you understand it more thoroughly for the complex examples. So if we were to average 10 and 20, you would add them up. And then you would divide by however many there are. And there's 2. It's always going to be 2. And of course, you would get 15, right? That's how you count. 5, 10, 15, 20. If you would rather do it by working it out, 10 plus 20 is 30, divided by 2 is 15. But let's do another example, one that I feel like you'll appreciate a little bit more when you start doing your work. Okay, there's another mid-segment. Let's say that this is x plus 4. And down here is 3x plus 12. And you're trying to average those. It's the same concept that you used up here with the easy numbers. You're going to add up the two bases. So we added them up, and then we divide it by 2. And that is equal to our mid-segment. That's what we're solving. So you would just combine like terms. So 3x plus another x is 4x. 4 plus 12 is 16. Divide it by 2. And then when you cut both of those in half, you have 2x plus 8. Yes, or x plus 4. Thank you. Simplifying it all the way down. Okay. Or you might have some other numbers in there, but the idea is you need to know how to set it up. Once you've got it set up, you're good. You're going to add them up and divide it by 2, same as we've always done. Actually, no. Well, no, we would not go. Actually, yeah, I'm glad you asked that. Thank you. We don't need to do x plus 4. And here's why. When we simplify it and we divide by 2, the denominator goes away. So it is just 2x plus 8. Because now there's nothing on the bottom to reduce with. Yeah. And then our last property, number 4, is that angles on each end of a leg are supplementary. Angles on each end of a common leg are supplementary. And supplementary, as we've said already today, means they add up to 180. I'm going to draw our diagram over here. This is where I've got room. And I'm going to use some color coding. So the legs are here and here. So that means that these two angles equal 180. And then separately these two. Okay, that's a lot of arcs, sorry. So I'm going to circle them instead. So there's a total of 360 degrees inside all the quadrilaterals, and you should remember that from middle school. But you can see it here, 180 and 180. All right, so now we're up to isosceles trapezoids. We have just 3 more things to write after we give ourselves this reminder. Since an isosceles trapezoid is a trapezoid, it has all 4 properties of trapezoids plus some others, 3 others specifically. And these are all pretty short. So we're going to start numbering this with number 5. So on number 5, it has 2 congruent legs. Again, the name is important because sometimes you're not going to get a picture, you'll just get a description. So on your trapezoid, these will all look pretty normal. There's your bases. So that means these sides are congruent. So your legs are here, here. Property number 6, the base angles are congruent. Okay, so your base angles are connected by a base. So you've got this one and this one, and then you have these two in the top. Again, with a bit of color coding just to show how they're connected with those bases. Now notice this is not necessarily true on the other set of trapezoids, right? You can look and tell that like this angle and this angle, they are not congruent. This one's acute, this one's obtuse, okay? Of course, those would not be base angles anyway, but you can tell here and here. This one's a right angle and this one is not. This one's a right angle and this one is not. So only on isosceles. And the last one, number 7, the diagonals are congruent. So on your trapezoid, that's a terrible, not isosceles, trapezoid. But let's pretend. Here's one diagonal going this way. Here's one diagonal going that way. You can tell they don't bisect each other. It crosses a lot higher rather than lower to where it would bisect, but they are congruent to each other. So in order to mark that, let's label our corners going around A, B, C, and D. Make sure you put them in a loop. And as long as you're in a loop, it shouldn't matter. It should be every A and C and every B and D. So no matter how you labeled it, if you just did it in a loop, AC is congruent to BD. Okay, so these are all of the properties of quadrilaterals. One big long day of note taking, but the good news is you will not get any new information this week. This is all the information that you need to know to do all of your assignments in iExcel. Please notice that you will have to set up some stuff, right? First, while I'm here, let me show you. You've got 6 listed. The only one that you will have to get to 90 is this one that's listed as number 6, properties of quadrilaterals. The other 5, if you just get them to 80, that will be fine. And if you, I think it takes like 7 or 8 correct answers in a row to get to 80. So, to get to correct answers in a row.
No, it takes more than that still.
Are you sure?
I swear.
Okay, well, I'll look at it again.
It takes like 40 almost.
Okay, well, I'll look at it again.
No, it really, it takes like at least 10.
Well, either way, even if it takes 10, that's 50 questions and you've got until Friday to get them done because you're not going to get any new assignments this week either, right? No new notes, no new assignments. It's all in there for today. So let's look at one of them and talk about setting up these problems. You will need paper because you will have to set up some equations. Now on one like this, it's super easy. It only gives you the congruent sides. You're going to set them equal and you're going to solve for Z that way. In higher levels, it'll perhaps give you 3 sides or it won't label them. It'll put them up here, but it's still all of the same properties from your foldable. So RU is a diagonal and TU is the other end of the same diagonal. And notice it says it's a rectangle. So you find rectangles and you look up their diagonals and you figure out that they're congruent. Actually, that would just be all, or sorry, they're not congruent. They're bisected. That's the property you're going to use. So you just set those equal and solve as well. And that's a property from a parallelogram column. GJ and IJ, same thing. The diagonals bisect each other, so these two should be equal. Even though these will have rectangles and rhombuses and stuff in here, this whole exercise, properties of parallelograms, the properties that you should use should be from that middle column about parallelograms, okay? Because remember, rectangles are still parallelograms, and so on. So I would recommend paper. You're going to probably need a calculator or want one, make your job a little bit easier. But this is not a mental math sort of assignment like the last couple of weeks have been. All right. Let me